Python Practice Problems, video number 4, Conditional Execution. I'm Stephen Marcus and I'm doing a series of Python practice videos. There's a link in the description to a short introduction video that tells who I am and how these videos are being done and what to expect. Also in the description is a link to this Jupyter Notebook without the answers so that you can go through it on your own, either before you watch the video or with me as I do the problems. Furthermore, in the description are a list of links to use as a starting point for your search for how to complete each problem. To use this video, I'm assuming that you have either gone through my first 3 videos or have a solid grasp on the Python print and input functions. Also, I'll be using Python 3. Okay, let's jump into number 1. Create a Boolean variable named addExtra. Print this is always printed. If addExtra is true, print this is conditionally printed. If addExtra is false, nothing else is printed. So this is the beginning one. It's pretty simple. I'll make the easy ones green. If you haven't done so yet, pause the video and jump out and try this one on your own and then come back for the solution. Okay, create a Boolean variable and add extra. Add extra equals, I'll get it there, false. Print this is always printed. Print. If add extra true, print this is conditionally printed. If it's false, nothing else is printed. Let's give it a shot. This is always printed. This other, it was not printed. It's conditional. If we change this to true and run it again, then I get what's conditionally printed. Okay, we can make this a little bit prettier. This expression right here where we're testing for true, this test is a little redundant because addExtra itself is either false or true. So what we can do is get rid of that and just have addExtra. So if I run that, true, so in both conditions it still works. Okay, let's look at number 2. Request an integer from the user. If the number is over 50, print the number is over 50. If the number is less than 50, print the number is less than 50. This one's pretty simple too. If you haven't tried this one yet, pause the video and hop out and then come back for the solution. Okay, so get an integer from the user. I'm going to make my variable and call it num equals input, enter an integer. Okay, the input by default is going to spit out a string, and comparing that to 50 is not going to make any sense. So I'm going to have to cast this as an integer. Then I can do my if. If num is greater than 50, print numbers over 50. Numbers less than 50. Now, I didn't have to test for less than 50 because there's really only 2 conditions. It's either over 50 or it's less than 50, so the else is going to catch everything else. Let's go ahead and give it a shot. It runs 25 is less than 50 and 800 is over 50. Now, one thing that I would like to do to make this a little bit prettier is this is called hard coding, and it's bad practice. What can we call a variable to represent 50? The breaking point. So I'm going to replace this with if num is less than b point. And really, to make this right, we can cast as a string that, and then do the same thing down here. Let's see if our code still runs. 800 is still over, 25 is still less than. I don't need it in there twice. I do need a space. There we go. It may seem like a small point, but in making this variable right here, it fixes it in 3 places. So now if I want to set it to 150, I can run it again and 200 is over, but now if I say 100, it's less than 150. So that makes it convenient. Number 3, create a Boolean variable named HaveDog. Print welcome to our bed and breakfast. If HaveDog is false, use 2 print statements to print please visit our library and come see our kitchen. If HaveDog is true, use 2 print statements to print your dog is welcome and free treats available. Then unconditionally at the end print we hope you enjoy your stay. If you've not tried this one yet, this is another easy one. Pause the video, hop out, and then come back for the solution. Okay, let's start with HaveDog equals false. Unconditionally, we're going to print to our bed and breakfast. If HaveDog, let's say you have a dog, print your dog is welcome, print free dog treats available. Again, there are only 2 conditions. Either you have a dog or you don't have a dog. It's a Boolean. So I can capture this with an else. Print this is our library. Come see our kitchen, and at the end print we hope you your stay. Let's get this up where we can see it. Okay, let's see if this runs. Visit our library, see our kitchen. That is HaveDog false. The stuff that's always supposed to be there, welcome bed and breakfast, hope you enjoy your stay, those are there. If I switch this to true, the stuff that's always there is there, and the other stuff is where it's supposed to be. The thing that I'm reinforcing here is grouping stuff together is done just with spacing. You don't have to have braces, curly braces, or anything like that in Python. Now, just as kind of a thought exercise, we can do this in the opposite way. If we said if not HaveDog, we would actually take these 2 and just swap them. So I have basically just swapped my 2 conditions. I've done the same thing. I've just, there you go, your dog is welcome. Yeah, it still works. So either one of these ways would work. Okay, let's look at number 4. Prompt the user for a string. Enter Forrest or Bubba. If the user enters Forrest, print have a nice day. If the user enters Bubba, print shrimp is the fruit of the sea. If the user enters anything else, print invalid entry. Okay, if you've not attempted this one yet, pause the video and come back. Alright, let's jump in. Name, that can be my variable name. Input Forrest or Bubba. That's going to return a string, but a string is what we want, so that's okay. If name equals, and if I've not mentioned this yet, a single equals would be an assignment. It would assign Forrest to name. We're doing a comparison, so that's why you use the double. Print have a nice day. Name Bubba, print shrimp is the fruit of the sea. Else print okay, let's watch closely how this works. Forrest or Bubba. Bubba, shrimp's the fruit of the sea. If I put in garbage, I get invalid entry. Now let's watch when I put in forest. I got forest, but I also got invalid entry. Why would that happen? Well, if we look at this, the way that it's set up, this else only goes along with one of the if statements. So the way that it operates, this is one conditional, and then this is a conditional just all on its own. So if you put in forest, this is true and it prints. Then when we do this one, it says, okay, it's not Bubba, falls through. Since it's not Bubba, it does invalid entry. So in order to fix this, we need to chain all three of them together. And in order to do that, we do elif, meaning else if. So if it's forest, do this, else. If it's Bubba, do this, else. There's your fall through. So let's run this again. There's forest. Have a nice day. And just make sure Bubba and then garbage. And there we go. Okay, moving on to number 5. Prompt the user to enter an integer, enter hour. If the user enters 7, 13, or 19, print time to feed the dog. If the user enters any other number less than 24, print do something else. If the user enters anything else, print invalid entry. Okay, if you haven't tried this yet, pause the video and come back for the solution. Okay, let's put hour can be our variable. Input, enter hour. Okay, the less than 24 means I'm going to have to do some comparison as an integer on this thing. So I'm going to have to say int to cast this as an integer. So hour is going to be an integer. If hour is equal to 7, or hour is equal to 13, or hour is equal to 19. And I put it in parentheses that time just to make it a little cleaner. Print time to feed the dog. So there's 3 different conditions that we can be in. We can be one of these, we can be a number but less than 24, or we can be a garbage entry. So, and they're going to need to be chained together. So I'm going to do the elif. Elif, it's going to be between 0 and 24. We don't want a negative number. So I'm going to chain these together. Hour, and hour is going to need to be greater than 0 and less than or equal to 24. Print do something else, print invalid entry. Okay, let's try this out. Enter hour 13, time to feed the dog. Enter hour 20, do something else. Enter hour 75, invalid entry. Enter hour negative 95, invalid entry. So all that works pretty well. This is sanity checking, just to see what all can be entered. What if I enter some garbage? I get a big crash. The big crash comes right here when I try to take this as a string and cast that as an integer. It can't cast that as an integer, so it doesn't have any choice but to just cause a big error. What we could do is to take the integer off of it and just take it as a string, and then we could do something like this and do comparison. You know, at that point these are not numbers, they would be strings, but when we come down to here and try to do a comparison, it's going to break there. So I'm not going to fix it here. I'm going to show you how to fix it a little bit later. Right now I just want to highlight the problem. There, it's still working. On to number 6. Prompt the user to enter a string. Say enter a string. If the string contains only uppercase letters, print that was all uppercase letters. If the string contains only lowercase letters, print that was all lowercase letters. If the string contains both case letters, print that had upper and lowercase letters. This one I think is kind of a fun one. If you haven't tried it yet, pause the video, give it a shot, and then come back for the solution. InString is going to be my variable name. I'm going to enter a string. And I do want a string here, so that doesn't have to be cast as anything or anything. If InString equals InString dot lower. This is the function that forces everything to lowercase letters. Print that was all lowercase letters. And I either need to put a space here or take that one out there. Okay, I've got 3 different conditions: uppercase, lowercase, or something else. So I'm going to have to do an elif, and I'm going to cut and paste here. If InString equals upper. And if I'm going to cut and paste, that had all uppercase letters. Else is going to catch everything else. Print that had upper and lower case letters. And before I hit Control Enter to try this, I usually look for my colons, because those are easy to forget, and it looks okay. Enter a string. This. That was all uppercase. That was all lowercase. This and that. That had upper and lowercase letters. So the whole trick here was I was forcing it all the way up and comparing it, then forcing it all the way down and comparing it. And if either one of those matched, then I knew it was either all uppercase or all lowercase. So that was kind of a neat one. On to number 7. Problem number 7. Prompt the user to enter an integer. Enter an integer. Print whether the integer is more or less than 50 and whether the integer is even or odd on one line. Okay, this one's not too bad. If you haven't tried it yet, pause the video and come back. Okay, let's start with the prompt. I'm going to make my variable number n equals, I know I'm going to have to cast it as an integer. Input, enter an integer. So this is going to be a series of ifs. If number n modulus 2, that's going to give me there. That's going to make it even, and number n is less than 50. Print less than 50 and even. Let's just go ahead and try this one. Enter an integer 20, less than 50 and even 99. It just doesn't do anything. So there's a couple of things that we probably ought to do before we get too far along. This right here, this comparison, it doesn't need to be that complicated. The number n with a modulus of 2, if we leave that off, that's either going to be a 0 or some number other than 0, and Python can figure that out. So if this is anything other than 0, that's actually going to make it odd. So let's change this from even to odd. So there's that, and I've got this and this, which is hard coding, which is, it's bad practice. I'm going to call that breaking for my breaking value. So I'm going to change breaking, and then I'm going to have to make this a little bit more complicated. String breaking, and then plus, and I need another quote. All right. So now it should be checking for odd and less than 50, which 23 is, and that worked. 24 shouldn't do anything. 99 shouldn't do anything. But we've got our code looking a little bit better to carry forward with. So I'm going to start with the cut and paste. So if it is more than that, we're going to say more than string and odd, and then I'm going to copy all of that. There's my other two. These two are going to do what I want. I'm going to have to say not and not. So these two are going to be even. Okay. And there's never going to be a chance that this is going, that the answer that is taken from the user is going to match more than one of these. So really these need to be elifs. And we can put an else at the end, print something really went wrong. Let's try this out now. So a number greater than 50 and even would be 100. Greater than 50 and odd would be 99. 23 would be less and odd. Yes, and 22 would be less than 50 and even. Okay, so that looks like it works. There are more ways to do this. I'm going to leave this here and add a cell, and let's look at it. Look at another way to do it. This may even be a little bit more elegant looking. Breaking equals 50. I'm going to set two variables. I'm going to create a variable called even state to tell whether it is even or not. Even. And over state to tell whether or not it is over 50. I'm going to start it out with less. I capitalize it because the way it falls in the sentence, it should be, yeah, it's the first of the sentence. So if I got to get my number first. So I'm going to just steal that. Now I can work with my if. If number n modulus 2, that would make it odd. It's even by default, but if that happens, then it is odd. And I can change even state, that's me, even state to odd. Then I can say if number n is greater than breaking over state equals, how do I say it, more. Okay, so now I can just print. One neat thing about it is overstate and even state are both strings already, so I don't have to worry about casting them. Overstate plus than plus, now breaking actually is an integer, and plus even state. Let's try it and see what we get. Enter an integer. 100 should be even and over. 99 should be more and odd. 23 should be less and odd. 24 less and even. Alright, so that actually maybe take up a little less room and isn't quite as monotonous. On to number 8. Number 8. Prompt the user to enter an integer. Okay. Print whether the integer is evenly divisible by 2, 3, 4, 5, and 6. If it's not evenly divisible by any of those, print kind of looks prime. Okay, if you've not tried this already, pause the video and give it a shot and come back. We'll say number equals, I know it needs to be an integer, input, enter an integer, just like we've been doing. Okay, figuring out whether it's divisible by 2, we've been doing that, so it's not a big deal. I can say if num modulus 2. Now that can either be true, meaning any number, or it can be 0. So if I do it this way, print number is evenly divisible by 2. And just with that little bit of code, let's see if that'll actually run. If I put in 8, it doesn't do anything because that returns a 0 because it goes in evenly. So it should be working off the primes. If I say num, yeah, so I've got it backwards. What I need is a not right there. So that means if this returns false, meaning that there is no remainder, and that's what we want. So let's run that again, put in 8, there we go, evenly divisible by 2. So I'm going to have a series of these statements that's going to be for 3, 4, 5, and 6. So I've already got hard coding in here, which I don't like. So I can kind of kill a couple of birds with one stone by creating a variable called div. And the first time I run through it, I'm going to give it 2. And then I can replace that with div. Now I have to make this look a little bit prettier. Divisible by plus str div. And let's see if my code still works. 8 by 2, and it shouldn't print anything there. And what that actually allows me to do is it allows me to cut and paste this a little bit easier. There's 3, 4, 5, 6. So all I have to do is change 3, 4, 5, and 6. And let's see if that still runs. If I put in 8, that should be divisible by 2 and 4. Okay, so that works pretty well. One thing that we don't have yet is a way to bring out this kind of looks prime if it doesn't match any of these. We've already seen if I just throw an else down here like that, it's only going to apply to this last if. So that's not what we need. I could go through and make all these elifs, and I don't even think Python will let you get by with that because of the way each one of these is actually exactly the same. I think that confuses it. And even if it did work, it's not what we want, because the elif would be if there was only one of these that worked. You could actually trigger all 4 of these, 5 of these. So you're going to have more than one. So what we need to do is to set up a flag, and I'm going to call my flag prime. and I'm going to set it to 1 just to make it easy. How about I set it to true? It's a Boolean. It's either prime or it's not prime. So that's cool. So if I can get through all of these, then it is prime. I don't need that else, that's going to crash. So any one of these, if it does work and it is evenly divisible, that prime doesn't need to be true anymore. So I'm going to take this and put it after each one of these and say prime equals false and knock down that flag. If it's divisible by 3, it's not prime. If it's divisible by 4, it's not prime. If it's divisible by 5, it's not prime. And if it's divisible by 6, it's not prime. There. So finally, at the end of all this, I can say if prime, meaning that it's still true and hasn't been knocked down anywhere. This is where I can do my print kinda looks prime. It's a bit much to get on one page right there. Looking for an integer. Let's look at the first one. 18 should trigger a bunch of them. 2, 3, and 6. What was another one I did? 20, 21, and 59. 21, it's divisible by 3. And 71 should be prime. Kind of looks prime. Okay, so that was kind of neat. Kind of a neat use of a flag. Moving on to number 9. Number 9, create Boolean variables for year and song. Prompt the user to enter the first name of a beetle. Print the full name of the beetle specified. If the song is true, print the song. If year is true, print the year. So you're going to put in a beetle's name and return what its full name is. And then, determined by whether or not these two Booleans are set, year and song, it will also print a song that they did and the year it was written. Okay, go ahead and try this one and then come back and unpause the video. Okay, let's create my Booleans first. Year equals false, song equals false, name of the beetle equals input. Since I'm just working with a string, enter the first name of a beetle. What can be our first beetle? If beetle equals John. Okay, we're going to print the beetle's name regardless. Print John Lennon. If year, meaning if the year was triggered, then it needs to be it's 1965 and help. Print 1965 if song print help. Let's see if this runs. John Lennon. Okay, how about if we put in true? John's our only beetle right now. It does print the year. There's the year and there's the song. Okay, one thing we can do to tighten this up a little bit, since it's not a lot of stuff that I'm printing, I can do this. I'm actually putting what I want to do on the same line as my if. So now I can tighten this up a little bit. Let's do Paul. Paul McCartney, And let's see, Blackbird and 68. Blackbird. George. George Harrison. Here comes the sun in 69. Sun. And finally, Ringo. One O in Ringo. Yellow Submarine 66. There's our 4 Beatles. We're only going to specify one Beatle. It's not going to match more than one Beatle. So these need to be else-ifs. So it's one great big else-if, else-if, else-if. And then finally, my catch-all for bad things, print invalid entry. Okay, let's see if this works. First name, Ringo. Ringo Starr. Let's do George. George Harrison. Here comes the sun. Let's do garbage. Invalid entry. And one last thing. Yeah, let's take out the year. Just to make sure. And George. Yeah, that's what we wanted. What this highlighted was, this is a nested conditional, ifs underneath an if. And we also saw how to tighten up an if into a single line when it can be really small. Okay, moving on to number 10. Problem number 10. Prompt the user to enter an integer. Enter an integer from 1 to 5. If 1 is selected, print edit name. 2, edit address. 3, edit passphrase. 4, edit payment method. 5, edit default language. This is just a simple menu and just asking for a response from the user. This one's pretty simple. If you'd like to pause the video and go give it a shot, go ahead and do that and come back for the solution. Let's make our variable called choice. And it says enter an integer, input, and integer 1 through 5. If choice equals 1, print edit name. Now, out of these, only one of them is going to work. So this is going to be a opportunity to use an else if. So else if choice equals 2, print address passphrase. Okay, so there are my choices. I guess I'm highlighting how Python will let you get away with different spacing. You can choose the look of your of your choice. And let's do a catch-all. Else print invalid entry. So let's see if this works. 3, edit passphrase. 2, edit address. So what would be nice to have here is something called a switch or a case statement that would simplify this, so you don't have to have else, if, else, if, so much of that. Some languages simplify something like that just for this application. Python doesn't have it. Let's try one more thing. If I put in garbage, what happens? Yeah, I get the problem here. If I put a string in, or this is going to return a string, if I put in something that's not a number, it crashes when it tries to convert to an integer. Now in this case, we could take out the cast to an integer and then do something like this. And run it again, and if I say 4, it's okay with that, but now it's operating completely on strings. So 4 doesn't have a value, it's just a string. So if I wanted to do any kind of manipulation with that, compare it to something else, it's not going to work. So number 11 is going to help us with that. Number 11, prompt the user to enter an integer. Print the absolute value of the integer. If text is entered instead of an integer, the program should not crash, but should print that was not an integer. Okay, pause the video here if you want to go try this, and then come back for the solution. Okay, let's jump in and try this. Input string equals input enter an integer. Okay, the way try and accept are going to work, anything that you think might crash needs to be put under try. That's why I'm not immediately casting that as an integer. This will work just fine no matter what you put in. It'll just put it in as a string. So now I'm going to go and do my try, and here I'm going to say input int equals. Now I'm going to cast it. That way, if that fails, it'll kick on down to my accept part of it here. Now I can use that as an integer. If input int is less than 0, input int equals input int times a -1. So it's just going to flip the sign if it needs to be flipped. Then I can do my print statement. The value is, now I'm going to have to go back to casting it back again to a string. Input int. There we go. And then for my exception, print that was not an integer. And it looks like I've got colons everywhere I need them. Let's give it a shot. Integer 18, integer -25, 25. And now if I put in garbage, that was not an integer. Now again, to tighten this up a little bit, what I did works, but we also can use input int equals. See how ABS turns green? That means that Python knows what it is. It's already got a function for absolute value of something. So let's try it again. -44 turns it into 44. So that's a quicker way to do it without having to do it manually. All right, the grand finale. Problem number 12. 12 is not really all that bad. It's just got a bunch of small pieces that all have to be dealt with. Prompt the user to enter a float. Enter unit price. Prompt the user to enter another float. Enter quantity. Units 1 through 5 are full price. Units 6 through 10 receive a 5% discount. Anything over 10 receives a 10% discount. So if you look at this too quickly, you'd say, okay, if somebody had a unit price of a dollar, and they ordered 100 of them, it'd be 90%. It'd be $90. The math is a little bit more complicated. You have to stage your discounts. So if someone had a unit price of $1 and they ordered 100 of them, the first 5 would be a total of $5 because it'd be full price. 6 through 10 would be $4.75 because it would get a 5% discount, and the remaining 90 would be $81 because those 90 would get a 10% discount, and your grand total would be $90.75. So you got to make sure that the math works right. If you haven't tried this yet, now would be the time to pause the video and hop out and work on this and then come back for the solution. Okay, well, the first thing that we need to take care of is bringing our data in from the user. So our first variable is going to be price equals input enter unit price. Quantity equals input enter quantity. There's price and quantity. Their value, they're actually going to be strings, so that's okay. And I know that I'm going to have to deal with the whole, if they put in a string, this shouldn't work. It can't be converted to a number thing. So I'm going to go ahead and do my try, and I'm going to do my conversion. Price equals, I'm going to cast it as a float, and the same thing with quantity. And this looks weird, but it actually works. You just, without using a separate variable, just go ahead and cast this and put it back into itself. And that actually does work, even though it looks a little bit odd. If I've got to try, I'm going to go ahead and do my accept. And my accept is going to be print invalid input. And that's going to handle if it says enter unit price and somebody puts in Fred, and Fred gets to be try to cast as a float, it's not going to work, and then that's going to pick up the accept. Okay, let's go ahead and do the first little hunk of it because the math is pretty simple. I'm going to say if quantity is less than 5, let's start up another variable called total, and the total is really simple. It's full price, so it's just price times quantity. And then I'm going to want at the very end print total, and then I'll have to cast back as a string total. Okay, I'm going to go ahead and try this. I've learned after years of writing code and watching students write a big bunch of code and then try to debug it, that you're better off writing small hunks of code and keeping control of it and doing your debugging as you go. You can maintain control a whole lot better. So I'm just going to run this and make sure that I don't have syntax errors or anything. Unit price 1, 3, 3. So it actually made some sense and didn't cause any big errors. So I feel pretty good about it. Let's try a couple of other things. Let's try if we give it unit price of 3 and a quantity of Fred, and I get invalid input. Now, there's still lots of things wrong with the code. There's a lot of stuff that we have to work on. One of the things is if I say a price of 5 and a quantity of -5, it has negative numbers which don't make sense. So that's probably the next thing that we need to tackle. So in order to disallow negative numbers, I'm going to need to throw in another conditional. If quantity is less than 0 or price is less than 0, and I'm going to try to be more consistent with my spacing because it's been pretty bad up to this point. Okay, so if my quantity is less than 0 or my price is less than 0, then put my colon in, print no negative values, which means that all of the rest of this is going to have to be part of a large else. So I'm going to highlight this and hit tab, and Jupyter Notebooks is going to tab it off for me. So all of this only executes in the event that this doesn't work. Now, if we put this up here before price and quantity, what problem would that cause? Well, if you did this and the impulse is to try to put it at the top, quantity and price at that point would still be strings, and a string can't be less than 0, so that doesn't work. That's why I've got this dropped in below my conversion of my variables here. So that looks like it makes sense. Let's just jump through and try it again. Unit price 1 and 4, and that makes sense, and 4 and -8. No negative values. Okay, so that's making sense. All right, the next step begins right here. If quantity is less than 5. Right now, the way that we've got it, 0 should kick out an error, so I'm going to change these to equal. There. So if my quantity is less than or equal to 0 for either one of these, it's going to dump out and say no negative values. So 1 would work, 2, 3, 4. This is only going to work if it's less than 5. So let's work on this. It needs to be less than or equal to 5 because the way that it's worded, 1 through 5. So 5 is included in the full price. 5.1 would get the discount, but 5 wouldn't. So also, this is hard coding. This is not a good thing. So let's see if we can get rid of our hard coding. So we're going to have 2 levels. Level 1 is at 5 and level 2 is at 10, and they're going to receive 2 different discounts. So discount 1 equals 0.05, that's a 5% discount, and discount 2 is 0.1 or a 10% discount. So now I've variabilized all of my points here to make it a little bit easier to deal with later on. So I'm going to take this 5 out, and that actually is level 1. And again, just for giggles, I'm going to run this thing 1 and 4. What if I say 1 and 5? Yes, it did catch my 5. Okay, so we've got it pretty solid now, and we're ready to move on. The next step to take is working on the next level of discount. So if level 1, this is going to be one of those 3-way comparisons, less than or equal to, because it's going to include that 10, and instead of 10 I need to put level 2. So if quantity is more than level 1, which is the 5, and it's less than or equal to level 2, which is our 10, then I'm good to go. Now I'm going to rework my total. Total equals our level 1, which is our 5, times price. That's our 5 that don't receive a discount, and we're over the level of 5, so it's just level 1 times price, plus whatever the quantity is, and quantity is going to be something between 5 and 10, but I'm going to need to take out level 1, which is our 5 in this case, times our price, times, we've got to get this discount into a format that's going to make sense. So it's got to be 1 minus discount 1. And I want to group all this together. And if you want to ridicule me for using too many parentheses, I say go right ahead. Too many parentheses is not a problem. Too few definitely is. And a lot of times I'll use parentheses just for my own thinking, just to make it clear to me. So I think that this is straight, and we can try that with 1 and 9. Let's give him a shot. Let's see what we're supposed to come up with. I'm supposed to come up with an 8.8. 1 and 9. There we go. So $8.80. So I feel pretty good about my second level of discount. Ready to jump onto the third. If, and this is easy enough, if quantity is greater than level 2, all of this is going to receive the 10% discount. And I can actually sort of copy what I've done above, and I'm actually going to just do that. Boop. Now this has to be changed. I have to take the quantity out. my quantity is going to be level 2 minus level 1. So that is the difference between the two levels. You can't just take for granted that it's 5 anymore. Times the price times your discount, and that's going to get your first level of discount right there. And finally, I'm going to add quantity minus level 2 times price times 1 minus discount 2. And again, I'm going to just put this all in parentheses so that it's all together. Okay, let's scroll back up, and what's my 1 and 12 should give me 1155. So let's run it. 1 and 12 give me 1155, and my original 1 and 100 should be $90.75. There we go. Let's go back just for a second and look at an issue. If I said 1 and 9, it gave me 8.8. So kind of as the cherry on top of all this, let's go back and fix the way that the total is represented. To F format total, and this formatting is going to give me basically a money format. 100, and it was 1 and 9, so they're $8.80. The logic on it is a little hairy, but it makes sense if you look through it. And that's number 12. Thank you for watching. If you feel that you've gotten anything from this video, please hit the like button. This video is one of my first Python practice problem videos, so I'm anxious to see if there's enough interest to continue creating them. If you'd like to be notified when I create new Python videos, please hit subscribe. If there's enough interest, I would like to create more Python videos that go beyond just the basics. I would like to eventually do problems that are more like you would find in a real-world environment. I would also like to consider branching out into other languages like R or C++. Thanks again for watching.